Good morning, good afternoon, good evening. Welcome into Learn Grasshopper Live. We are continuing our workshop from yesterday, day one. We talked about delivering, exporting and importing IFC from Rhino. In day two, we will jump into Revit. Revit workflows, how we can also export and import things from both Rhino and Grasshopper, and how the BEAM software can help us with Revit. Hello, Mikael. Hello, Mauro. Can you hear me?
Yes.
Hi, Chris. We can hear you well.
Hi, Chris.
Again, thanks for yesterday. I got lots of good comments. Lots of people been engaging into the chat, so that's good that we are not talking for just ourselves. I've been using your software, so it also was fun for me to see new features like this table with scheduling and filters. It looks like you're going in the good direction. Is it your 100% work, what you are doing on the product, or you are also doing some architectural stuff?
Generally, we are working mostly on these products, on BEAM and RhinoSync. We don't work on purely design work, so we don't work as an architect in typical terms, but also we support companies for workflows and BIM and the technology, the design technology part of many companies right now. So we are also doing some consultant work for them, but yeah, we are not working on the design.
Mm-hmm. So how to do this transformation from being like a standard architect into the person who's building your own software? It's like a huge change in the work and like how do you work, and what with technology you are working with?
Yeah, I mean, generally speaking, I think we have been, and I hope I can speak for both myself and Mikael, but we've always been very interested in design, but also in the process of creating the design, and especially with the design tools. So it's been now like almost probably more than 10 years that we are building, that we started to build the Grasshopper scripts, automation, macros, Dynamo scripts. So we have been always interested in design, but more also a lot in the process and the workflows. And that's, I think, it is the way we partnership with Mikael for this venture. Right, Mikael? Do you want to add something?
Just the natural evolution of our careers as a computational designer and BEAM experts. So we enjoy pretty much this side of the project. It's still part of design, no? Like in a way, everything goes into the project, the deliverables and workflow. So we feel we are part of the design, maybe not the creative, drawing part of it. But definitely, we are still involved in architecture projects.
Yeah. That's great. So you say that it's everything started with first Grasshopper scripts, or it was something before?
Well, Dynamo and Grasshopper were I think one of the first ones we approached. Back then.
I think they were definitely the entry point to then get into Python, eventually then C#, and then starting to build application with more like professional people from the actual software development from the software development industry. So that was a natural path. But I think Grasshopper, and this is what we say many times in webinars and also with some students, and you might also agree with this, that for us, Dynamo, Grasshopper were the entry points to then move to some other visual programming languages. So moving from visual programming languages to other languages. Yeah.
I always say to my students, it's like in my first lesson, I always say that it's that they should be careful because it's addictive and it's a drug. You begin with the soft drugs like Dynamo, Grasshopper, and then you go, as you guys, to hard stuff.
Yeah.
Now everything has to have dictionaries and hash tables, otherwise
It's endorphins, right? Endorphins. Every time when you automate something, you see something you develop, the endorphins are coming. All right. So let's start day number 2. So for those who are seeing us for the first time, haven't seen yesterday's workshop. So yesterday we had a workshop, also 2 hours, about managing IFC in Rhino and Grasshopper. We talked about assigning all the BEAM data, levels, property sets, Rhino objects, controlling IFC export and import. So lots of great stuff for those. If you register after that, no worries. We are going to send all recordings and also the files that been presented. And today we will jump into Revit workflows, and maybe if it will be time at the end, we will also talk about new development from MKS that we show RhinoSync, so it will be cool stuff. Session today about 2 hours, not longer than that. Mikael was tired after yesterday, just presenting a lot of stuff, and I know you also, but I think it will be 1.5 to 2 hours. It will be more than enough recordings. If you still haven't registered, go to learngrasshopper.com/revit-beam, and you will get all the recordings and materials. And as always, we are here for you. So if you are writing comments, so we will be glad to answer it. I was really happy to see so many comments that you actually use. It's motivation for us, and just confirmation that someone is behind the camera. So good if you will write, if you are with us. Already a few people just write hello from Morocco. Hello, nice to see you. All right, let's start with some introduction for those who missed yesterday. Mauro, maybe you can just make a small introduction. What is MKS DTech and what is BEAM and your company doing?
Great. So thank you, Chris, again for organizing this webinar. We had a very good feedback yesterday. We are really happy about this. And today we're going to move to part 2 and BEAM in action with Revit. First of all, we are MKS DTech. So we are architects that turn into coders and programmers. So we use our expertise to build applications for architects and the AC industry. This is Mauro, and Mikael is with me, and he's going to show you a lot of stuff when it comes to the interoperability Rhino Revit.
One thing, MKS, it's a shortcut. I was trying to figure out yesterday about your names and surnames, but one letter was missing.
The K, I think you can figure out what the K comes from.
Yeah.
So it's a small anecdote, maybe I can tell you. So when we started working together in Hadid, Mauro and I, we had a personal folder on the network drive, and those were your initials. But Mauro and I will have the same initials.
Yes.
MS, and I said, okay, I will get MK, right? And so when we started working together, we created a common folder that was MKS back in the days. So we could, put together things that we kept sharing each other's scripts and content, and so that little folder became the name of our collaboration.
Yeah.
Okay, nice. I was thinking that K stands for Chris, and you were going to invite me to your company.
You never know. Maybe.
All right. Let's continue.
Yeah. So we are creating applications for the architects, and our mantra, our motto is to bring back time to design. So we want to simplify and improve the workflows in the AC industry. And we do this by, let's say, embedding wrapping our experience of architects into design applications and plugins and software, generally speaking. And we try to make them as simple as possible to simplify and to make your day in everyday work in architectural practice a little bit better. So we really like Rhino. So today is going to be about Rhino and Revit interoperability. But when we talk about BEAM, we are trying to add a layer of BIM data to Rhino, so adding data structure and collaboration to the design workflows, starting from a great software that is Rhino. We really like Rhino, great modeling tool, but we think it lacks a little bit of BIM functionality. That's why we are really focusing a lot of adding these functionalities into Rhino, and this is our goal for the future. And so today the focus was going to be on the interoperability between Rhino and Revit. And with BEAM, as I mentioned briefly, we are adding this layer of information to the object, so you can add attributes, properties to the objects in Rhino, create effectively BIM objects in Rhino, and then you can export them to Revit, and also, as we have seen yesterday in the webinar, also to IFC, and creating IFC models directly from Rhino. And you can, yesterday we went through this in detail. Import IFC is available as well. Go and watch the records from yesterday. So export, import IFC is available, but today we're going to focus on the interoperability between Rhino and Revit. And this is also how BEAM started. It started to connect the two platforms in a very simple way. And this is where we are today. So we are also very proud of BEAM being used in the top practices in the world, from Herzog de Meuron to Big, Cox, Edelwick Studio, and so on. So we have many practices, the top practices, I would say, that are using BEAM at the moment. We get a lot of feedback from them. Also, we collaborate with them to make BEAM always more solid and to include new features and so on. So this is great for us to be the extension of the use of BEAM, and also the general user that are great. A few technical aspects and compatibility aspects of BEAM. BEAM is available for Rhino 7 and 8 from Revit 2018 to 2026. When it comes to IFC, we export and import IFC 2 and 3 and IFC 4. For today, and so for the audience of learngrasshopper.com, we are also providing a trial license for a few days, so you can use BEAM without any limitation. You can copy and paste. You can use the credential that you see on the screen to access the full version. Chris, do you want to add anything about it?
No, we can start. And yeah, Mikael, the stage is yours, so I can just put it on your screen. Thank you, Mauro, for this introduction.
Let's make sure to share the link of the beta to the chat again, so they can use.
Yeah, you can just in the private chat, if you can just copy that, so I will put it on the chat. Okay. Thank you, Mauro and Mikael. Let's connect these two words. How we can connect Revit and BEAM.
Okay, so we have Rhino open now, and that's where we will start modeling our content, and then preparing the information to be sent to Revit. So on the right-hand side of the screen, I will repeat a few things that we said during yesterday's workshop, but some of you might be new to this and haven't attended yesterday, so we'll repeat a few of the core functionalities for BEAM, and then move on to the workflows. So on the right-hand side, I have my BEAM panel. If you don't see the BEAM panel because it might be hidden or turned off, you can click on the option wheel here on the top right corner, click on Show Panels, and then select BEAM in the list of available panels. Okay, so if you turn it on and off, it will show the panel. So the panel is comprised of a few areas. So very importantly, we have the About, so you can see the version. In this case, we are using 1.13 beta. You can also see this shortcut here. Older versions might not have this version on the panel. Then we will have our login. So you should log in here with the credentials we have sent you, so you can access the full features. BEAM also comes in a free version that has some limitations in terms of how many objects you can export or import. but any other feature that is in Rhino assigning parameters and values that does not require a license. Okay, so here we have the BEAM Exchange folder location. We'll see that in a minute. Some tools for finding families in the file, creating parameters, querying data in the document. And at the bottom, we have our export-import buttons, okay, including the IFC settings dialog, which we covered yesterday. So let's start. We have this geometry here. We are in rendered mode, so these objects don't have any material assigned. There is nothing assigned to it, and we want to start creating a family. Now we are starting to talk about loose geometry, which means geometry not inside blocks. Geometry inside blocks, there is another, let's say, part of this demo that we'll show, but for now we are focusing on geometry not inside blocks. So as I click objects, the panel will display what information is attached to this object. In this case, we don't have anything, and the basic information we can attach to loose geometry is the family, which will contain the elements and any other element assigned to the same family, so we can group them into a family instance. The subcategory, which will be created under the category of the family. Okay. If this subcategory does not exist in Revit, it will be created. So you can type the name and it will create it. If it exists, of course, you will use the existing subcategory. Then the material. The material, important to know, is that this is the Rhino material. So if I assign a material by using Rhino tools, for example, I go my material tab and say assign to objects, still, when I go back to the BEAM panel, still is assigned. So whether you assign by object or by layer, these will be reflected in the panel. But with the panel, I can also change it. For example, I want to change it to brass or to glass, right? Let's put it back to the brass. Be aware that by doing so, you will change the assignment to object. So if it was by layer, then you change it here, it will be like assigning by object, because of course we're editing just this specific element. Another cool thing is that you can, first of all, you can type and it will search, right? Existing, it will autocomplete for you. But also, if you type new material, for example, it will create a new material in Rhino. So I can then very quickly change the appearance. So it's a very quick way to create a material just by the panel while you're visualizing the data. Okay, let's put it back to brass. Okay, put it back to brass. Also, I want to change the subcategory of this object. So I will say that this is my cladding subcategory. Then I will assign it also to this object. This will be my glazing element. And then I will add glass here. Okay, so now I have a glass piece. Then I have a cladding part made out of brass. And I will leave this frame here with no material and no subcategory assigned, so we can see what happened in that case, right? Next, and BEAM is very simple to operate, right? So we've seen it yesterday, but now just to go quickly, I can also select, I can now select all the objects and then assign them to a family. In this case, I will create a module family, right? As I press enter, I have access to other properties of the actual module family. These were the object properties, as you see, and then now we have access to family parameters, family category, and IFC data. We'll ignore IFC data for today workshop. So let's start with category. This is very important. These are all the categories available for loadable components, and maybe some trick loadable components we have done, but you can choose many categories from Rhino. So we can say this maybe is a furniture piece or is a roof, for example, up to us. Let's bring it back to generic model. So you can choose what category you want the family to be in. The second part is parameters. So we have family parameters in instance and type for these objects. So instance will be specific for each instance of the family and type common to all the families. However, here we are talking about loose geometry. So there will be only one instance of that family. Imagine like this is an in-place family. So it will behave like an in-place family. If we want to have different parameters for different instances, we need to use blocks, and we will see that later during the presentation. So by default, BEAM comes packed with a few default parameters, which will be comments, mark, work set, keynote, and type mark. all the other parameters you see here, I have added them to my parameter set. And so to do so, if I want to add more, I can just click on the P button on the panel, and this will open my parameters manager, where I can see all the parameters available in the file. I can add more, remove them. For example, I will add one new parameter. I will call this new parameter, so it's clear to see. I can choose whether it's an instance or a type. I'll leave it as an instance. Then I can pick the data type. This is very important for FC. For Revit, although you might have assigned a data type here, we will still try to convert the value that you have put to the data type that is defined in Revit. So you can leave everything as text here, and then we will try to convert them to numbers if the parameters are numbers in Revit. However, it's always good practice to assign correctly the data type, and this is very important for FC as well. So let's leave it as text. Next, I can define the property set, which is also specific for FC, so it's kind of a grouping of parameters. And importantly, I also can check which categories these parameters will appear in. For example, if I want these parameters to be only available for ceiling families or ceiling and curtain wall, curtain panels, I can do so. In this case, I will just say, make it available for all families. Okay, so as I click OK, it will appear in my list. So I have my new parameter, instance, text, and assigned to set one. At any moment, I can remove, I can edit the parameter, not the name, but all the other settings I can change. And through this interface, we can also import and export parameters. And what is interesting is that we can also import share parameter files from Revit. So when you are, let's say, let's open a new Rhino file just to start from scratch, and you can see this. Also from this document, for example, I can export in JSON format my parameters, okay? So parameters. So I export it to my desktop. Let's open the file in Visual Studio Code so you can see the content. Parameters of JSON, that's it, there you go. And you can see in the exported document, we have in JSON format the list of parameters assigned, created. So name is instance type. So you can also create these manually if you want to, or export it, or any other way means you want to create this JSON file.
Mikael, one question from Chronis. Can we also define shared parameters?
So yes. So the thing is, in BEAM, these parameters, you create them in Rhino, but in Revit, they must exist. Okay, so BEAM will not create parameters in Revit, and this was a conscious choice of avoiding creating parameters by mistake, and that would be problematic.
I can imagine hundreds of new parameters being creating and duplicating, and with typos and so on.
Exactly. So if the parameter exists as a parameter in Revit, in the project parameters, for instance, then it will be populated by BEAM. So that's how you should work. So you have this.
And the next one. Sorry, and just one more question. Does parameter types or instance type have the same logic in Revit?
Yes, they do when working with blocks. So when we see blocks, you will see that they have the same behavior. Okay, so just to continue here on parameters, we have the default parameters in this blank new file, but I can also import, pick my JSON, and it will add all my parameters. So I can create this JSON as like a template to add to all the files that I need, or maybe I can generate it using Grasshopper, or as Chris suggested yesterday, using ChatGPT, whatever you like. You can create a list of parameters that you need. Okay, so let me cancel this. And also another way, you can import not only the JSON, but if you check here to text files, we can go, let me just go to my folder here. We can open a share parameter file from Revit, okay? And it will bring a familiar interface where we can pick from that file and create parameters from the share parameter file, so we don't make typos or mistakes, right? So that's another way to import parameters. Yeah, let's close here, go back to Rhino. So let's say that now I have these parameters, I have my comments, etc., my classification. Maybe I will say class 1, not sure, I could just put like Mars as my location, status completed, and I can start adding parameters here as I want to. For example, I will add my keynote, H100, my owner, MKS, DTech, and so on. So I can start adding parameters to my file. And if I change category as well, for example, go to furniture, you see some parameters disappear because those were not available to furniture. So classification, for example, is not part of the generic models list. So as I change, it will change. So it's an easier way to have a lot of parameters compared to maybe user text where you see everything, or it can be a little bit complicated. With this system. You can have a more refined way of adding parameters. And also, for example, in panel area, if I type letters, it will not allow me to. You can only type numbers. So all of this is managed through the panel very simply. Very similarly to how you would do in Revit. Of course, all the parameters we can collapse the property sets if we want, and this is an extra important feature if you want to resize, because some parameters might be, the name might be very big, you can resize them, okay? So that's pretty much it for the assignment of data and creation of parameters. I hope everything is clear so far. It's very simple. How to add them, as we said, name, all the categories that you can do, and then import and export. And then we associated a family name, set a category. In this case, we leave it as generic models, add a subcategory, material, add some parameter values, and we're good to go, basically. So let's start exporting. So I can select everything and press BEAM. BEAM allows you to export quickly blocks and loose geometry in one go, and curves as well for other workflows, for adaptive components. Another way you can do that, you can go on the F button. When you click F, it shows you the list of current families in the file. So I can say, okay, I want to find only module, and then I select the family, and it will find for me all the objects that belong to that family, provided they're not hidden. And that might be convenient because you could have, some things in the front, and how it could be annoying to select. Maybe you don't want to use the layers. Maybe they're not in layers, they're different layers. So who knows? So I can also control click and press select to quickly select just one or two families. So when I press close, I'm sure I have selected all that I needed to export. And I can press BEAM. And now we are in the export dialog. So first of all, location. Internal origin is, for us, the best workflow. You should have the internal origin of Revit and the internal origin of Rhino always matching. You should never model in world coordinates. It's always better to define a project origin, which is close to the geometry, is always on the bottom left corner. So all the coordinates of the vertices and everything is always positive, right? So all these good practices should apply. But in a case where you don't have control on this, or it was set up differently, or any specific means, you can pick any named C-plane as origin. And by named C-plane, I mean when you create a C-plane, place it anywhere in your file, and then in the named C-planes tab, you would go on save as, and then you can name it, I don't know, WCS. So that would be maybe the survey point and so on. So now I go back to F and I select module. I can also double click, then close, and press BEAM. And now you see WCS is also available. So it will use that as the origin for the export. So in this case, we're just going to use internal origin. Next, I have an identifier, and this is not the family name. The family name is in the object. Also, you can export as many families as you want in an export. You don't have to export one family by one family. So you can add as many as you want. This is the identifier of this export that we will use later to download the content, basically. So I will say that this is my module v1. So this has to make sense. Since this only contains the module and is my version 1 of this export, I will call it module v1 and just press BEAM, okay? In a few seconds, it's completed. What happens? BEAM saves this exchange file, temporary exchange file, in a location in your drive. We'll see it in a second. Let's switch to Revit, okay? So now we're in Revit, there is nothing here. And in my ribbon, I have my BEAM tab and all my BEAM tools available here. Also in this drop-down, we can find our About, as always, and also the licensing dialog. As I press, let's use the standard BEAM tool, no? That allows you to import geometry. It has maybe less dedicated, let's say, commands compared to blocks, but it will also import blocks. So as I press BEAM, I have my BEAM interface open here, and I have 3 buttons, the same as I have in Rhino, okay, to manage my BEAM directory. So all the files that I export will be saved when I click here on this button, okay, show open BEAM directory. It will open the current cache location, which by default is in your app data local BEAM temp. In this location, there is allowed to have a maximum of 50 files, right? So every 51st file is deleted. You can also set the directory to any location you want. So you can pick another folder, maybe on your machine, maybe on a network shared drive, and this is the common way of doing that. So everybody saves and reads from the same directory, and it's very easy to just set it in the app, and you don't have to browse every time, right? So I can define, for example, I want to save it on my desktop, okay? So my folder will be my desktop. Of course, there will be no BEAM files in that folder, but in this case, there is no limits on the amount of BEAM files you can have. And so it can be a collaborative, let's say, storage location where you save all your Exchange files. Maybe you want to use them another day because you want to go back in time. That's also, I will explain, is a benefit of a file-based interoperability. At any point, you can reset to your, let's say, current default machine location and keep working by yourself. So then there is a few settings here. Maybe we will have time to cover them, but bear in mind that 99% of the time, these settings are fine, right? So the only thing I have to do is to pick from this drop-down the BEAM file I want to import. These are listed in chronological order. Now I just did one export on this machine. So module v1 is only available, but it will be pre-selecting the latest one, okay? So this is like a file browser on that specific folder. So I'll just press BEAM and see what happens. And in a few seconds, I should get my content imported. So you can see I have my module family. It has parameters as I did assign to them. So I have my location marks, classification is assigned. My type parameters are also assigned, H100, my type mark as well. So all those properties were added. And on a plus, I also have type parameters for the materials used in the import. So, for example, I have brass. I have by category all the objects that had no material assigned, and then glass as a final one. Sorry, I might sneeze in a second. So everything looks fine, and let's have a look inside. Sorry for that.
So, bless you, no worries.
I was fast to mute myself. So here we are inside the family, and as you can see, I have my all my parameters as I wanted in my family, etc. All my type parameters. I click on an object, and is assigned to my subcategory as I wanted. The material is assigned to a parameter. It's a solid, and to a certain extent, it's also editable. Okay, if you wish to, you can edit. Okay, until it breaks. So your mileage might vary. You can also cut these with voice. So it's just a proper solid, really. So let me just set a work plane level this. So I can also draw something. Okay, and then I can cut these with a void if I wish to, like this, like so. So you see, so you can still edit it. So it's good geometry. Will cut well in section and plan, provided on certain geometries might be a little bit too extreme, but in generally it will work fine. And it supports solids and surfaces, sub-D, and meshes, right? So if you see here how it looks, I take this and stream it. You can see that it's pretty good, looks fine, and so on. Okay, so that was pretty easy to do and fast. Now let's see what happens if I want to update this component. So I go back to Rhino. Okay, let's delete this stuff, and I will start doing some modifications here. So first, I will pick these edges here. I will extend them. Then I will change the material to aluminum. Okay. And then I will want to add one geometry to the family. So I'll add this little box here. I click it. I go to my family, change to module. So it's added now to the module family. Then I will do a few new things that I haven't shown yet. So first, I will also create some curves. And I will move them down, okay? And these curves, I will, in the subcategory, I will add them to module as well. And in the subcategory, I will type hidden lines. And this is something that will improve with the next versions of BEAM. Next update, we will focus on more subcategories for curves inside families. But as of now, you have to use the default ones from your template. So I will add them to hidden lines. Another thing I will do, I will use the visibility settings property here that allow me to define, like in Revit, where this thing should, when this thing should show up. So for example, I will only show this in fine. And then I want this box to only show in course, right? Next, I will change some parameters. So I will change this to class 2. I will change this to in progress. And I could continue like that. So what I have done, I have added an object, added some curves, changed material, changed the shape of a geometry, changed the parameters of the family, and changed the visibility settings of some objects. Okay, so I'm now happy with this new version of this family. So what I will do, I can select everything in this case, okay, or use the F with module. But I can just select everything, press BEAM, and say module V2, and press enter. And this is exported. When I go to Revit, very easily, I can now go to my BEAM panel. Also, one shortcut will be to move it here so you can still have access to your Revit tools while having this floating toolbar. I will use BEAM now. Module V2 is pre-selected. You can see I still have access to V1. I will leave the default settings and just press BEAM. Perfect. So as you can see, I have my object. I should have changed also category. I apologize. So it's still generic model, but you can change the category of the family to furniture if you want to. So I have my new parameters of class 2 in progress. The materials changed. So I have aluminum here, and I have by category this one, and glass the other piece of glazing. So all the changes look fine, but what are the curves? Well, because very medium, but if I go into fine, I will get my lines. Okay, maybe this scale is not amazing. Okay, so I have my lines in my hidden line view. And if I go to coarse, it will show the other box. Okay, so I can use this to create different levels of details or show some geometry in certain specific views, more detail, for example. And so this will be easy. But what if I'm not happy? The advantage of using files or versioning local files, we don't store anything in the cloud. So you are sure that all your data is with you. We don't store any of your information, which is a pro for us compared to other cloud solutions that do a similar workflow. Don't store any design data, but you do. So you can go on V1 and press BEAM, and that will go back to that version, including parameters and everything. So we can use this at our own advantage, okay? So we've seen that we have modeled this family as an in-place family, let's say, because it has the origin of the family in the 0. So it will be just one instance. Another way to do this workflow would be to treat Rhino as a family editor, okay? So now some plugin is failing to load. So imagine I have, this file is in meters, imagine I have some sort of content that I want to do. So I model it in 0, of the file, right? And then I can name it cone family, right? With all the categories and parameters I need. So when I export it to Revit, I will go. I can not place instances of this family, of this import. And this will create the cone family in my file, which should be listed here, cone. So now I can place these components many times as I want in the file. And what happens is that if I make a change in Rhino, for example, expand this, since it's still the cone family, let's say new cone. When I go to Revit, and I press beam, new cone is selected. Now I can leave this also checked, because if there are instances in the file, it will not try to place them again. Okay, so this only works when there are no instances in the file. So as I press beam, it will just update the families. So you can use both as an in-place modeling something in the project location, but also use it as like a family editor where you model things in Rhino individually, and then you can just import it as a family in Revit, place it wherever you want, and use it. Okay, so I hope that this is all clear, and we will move to blocks. Not sure if there are any questions so far.
No, everything's clear. And it also changed my mind how I look at this interaction, that you can just easily manipulate and change families. And it's a great alternative for all the methods.
Exactly. So now let's move into blocks. Blocks, we find them very convenient, because in blocks you can repeat identical objects very easily. And so how BEAM sees blocks. When you click a block, the block is automatically a family, and the family name is the block name, which means that every time you create a block, you are sure that the name of the block will be a family in the file, and that everything you model inside the block will be part of that family. In fact, when I double click here on this object, I have access to my subcategory, material, etc. I have already pre-populated these because we don't have to show it again, but we have my cladding subcategory, GRC, material, and then in the family, I have some parameters here. For example, I have my comment one under instance, and then block type parameter as my keynote. Let's also change it to actually H100 like this. So comment one, as you can see, when I click on this block, it says comments two. However, the type parameters are the same. So someone asked the question before if they behave like instance and type parameters in Revit. Yes, they do in Rhino. So you can add type parameters for all the blocks, and the blocks will share the type parameters, but have individual instance parameters. Okay, so you can see every time I click on one, there is a different parameter. Okay, so as easy as that, we can just model, assign parameters, assign properties, change family category, exactly as we did before, but this time we have blocks, so they have advantages, for example, of having an insertion point. And when, of course, we will import them to Revit, it will create instances of the same family. So it will be lightweight import, it will be better for the Revit model. And also, it's easier to say, when you click, you actually select everything, right? While here, it might be not super clear which other components are part of this family unless you go on the F button and select. So this is a valid workflow, especially if you work as a family template, or if it's just a one-off object, maybe some landscape, etc. But when you start moving into some more detailed designs, maybe it could be useful to look into blocks. So I have all these blocks, and I could select all these blocks here and press beam and export. That's totally valid. However, we have a tool specific for exporting blocks that make it easier. Okay, so when I click on it, I can pick blocks manually, which will basically filter out my next selection to just select blocks, so I don't select anything else. But I can also do by block definition. This is a nice way to do that. So when you select blocks, you have this interface where we can see all the blocks in my file. I can search them. So for example, I want to just see some blocks. You can see how many they are. So this will only display non-nested blocks. So blocks that are in only at the top level. So if they're nested, they will not be shown. So I have 25 unit 1 and 2 corner unit. I can turn on preview selection, and then by clicking here, I can also see what I'm about to select, what I'm about to export, right? So in this case, I want to export the whole facade here. So I haven't clicked anything on the file, and that makes it safer selection. Of course, as always, things must be visible. So if you hide them in another layer, they will not be exported. Okay, now I can save this as facade B1. Okay, press B, and it's completed. BEAM is really, really fast. Okay, now let's use blocks. BEAM would work as well if you want to use it, but you will have less options. In fact, we're going to use blocks now. Blocks has a few more dedicated options for blocks. So first, of course, you have the list of exports, and facade B1 is pre-selected. Then we have a few two options here: import family or use existing. Now we are importing family, and of course we want to place families and update the parameters, and we want to set these families as work plane based. If you uncheck these, the family will be always vertical, and that's very good for maybe furniture and other pieces. But if it's a family that has to be placed in very weird positioning, then work plane based will be better. We'll do that because later on we will do some transformations. Okay, and then I haven't mentioned this before, but you can choose the location. We can choose internal origin, choose use the project base point, or if we use shared coordinates, one of the shared coordinate sites that we have available in Revit. Okay, and I can show that later, but they're under manage. You can create different sites. So one option would be that you can also create a site specific for the Rhino Revit workflow, and so you will create a C-plane and a site in Rhino and Revit that just are meant for this collaboration. But that's why the shared coordinates exist, because you can share coordinates with other parties. So you can also decide to create one site specific for the Rhino Revit workflow if you wanted to. Maybe one day we should do a workshop just about coordinates. I've seen this. I've said this a few times with Mauro. So let's speak.
Please do that. It's like one of the most asked questions and problems that I can see also on LinkedIn about the Revit coordinates. And I think like even architects and engineers are watching the tutorials. They are still fighting. And I also seen on my project that it's really often I got it in the wrong coordinate. So this is a good topic.
Yeah, exactly. So let's see what we have here. So we have imported everything very quickly. So we have our unit one. If I select all instances, I will see I have 25 instances of unit one. So pretty much what I wanted to have optimized. So I have my comments, mark, etc., all the parameters as I did with the other type of import. So it just behaves the same. This time instance parameters are different and type parameters are the same for our instances. The insertion point of the block is used as insertion point of the family, which was different from this one. As you can see, the origin of the file is insertion point. Of course, it's not in this case because we placed them manually, because rotating code is not very interesting. But in this case, we have the insertion point, and that allows us also to assign it to a level, right? So here in Rhino, I have set the families under IFC data. This might change in the next version. We might move levels somewhere else, but this was set to automatic. I could also pick a level that exists in Rhino if I created levels in my file that match the Revit levels. I could have created maybe another level 1 at 5,000 millimeters. In this case, I would be able here to assign it to level 1, right? And then in Revit, it will look for the level 1 level. So by searching for the name and assign the objects to that level. In this case, it was automatic, so it looks around in the levels and tries to place them in a level where it is above in the insertion point. So you can see this is exactly on or above the level 4. So we added there. This is level 3 because it's level 3. So there is an automatic assignment. However, you can customize that and force to use any other level that you have created in Rhino. Maybe we have to explore this a little bit more in detail if you have questions, but you can create levels. And when exporting to IFC, you actually create the level at that height and everything. In Revit, it will look for the level with that name. So the thing is with BEAM, for IFC, we create the objects in IFC. For Revit, we first ask Revit if they have that object or if they have that element. So for example, if they have the material brass, we use the material brass from Revit. Otherwise, we create one. And then for parameters, if the parameter exists, we assign the value. If it doesn't, we don't assign the value. If you assign it to level 1, if the level 1 exists in Revit, we assign it to level 1. Otherwise, we don't assign it to level 1, okay? So always Revit dictates the ownership of the things, and Rhino is more of gives information, geometry prepared in a nice way because we can create BEAM objects through the panel. But that's the general concept of it, right? So nothing much to say. We have our families here placed and all is good, but let's start doing some modifications, okay? And get into more depth of the blocks workflow that we like. So first we will change these to brass. Okay, so this should change everything to a golden tint. Next, I will pick this item, this instance, and notice that there was an automatic mark assigned to any block in Rhino, which you can also change. You can add it manually, or you can use Grasshopper to assign marks to all the blocks, right? So, for example, what you could do, I'll quickly open the Grasshopper here and just show a couple of things. So in BEAM, we have a few block nodes because there was no, at least in Rhino 6 especially, there's no way to actually select block instances very easily. So we added those to BEAM under the blocks, let's say, group. So you can say block, okay, which represents a block. And then I will say set multiple blocks, and then I can select these blocks. And now I have my blocks selected, all right? So I have my block instances. And from here, I could, for example, set a block parameter, right? Plug a mark value, for example, right? I plug the mark, I plug the list of blocks, and then I will plug the values of maybe sequence of marks, or maybe this comes from another workflow where I want to mark them based on the height or the level, whatever you want. You will plug the list of parameters here, and this will assign marks to your files. But by default, BEAM creates a mark for you, okay? And this allows us to track the object later on. So as I was saying, I will move this block, okay, and rotate it maybe upside down. It's very difficult to do in native Revit, so in Rhino it's very easy thanks to the Gumball. Okay, so I rotated this, and another thing I will do, I will also add an instance here. So this is a new instance. I will add the comment new instance, right? So this is rotated, and this is the new instance. Now I can just select what I've changed and press directly blocks and say add the new changes. Okay, and it's exported. It's very fast. Go to Revit. Now I go to blocks and leave default settings. Okay, so import family, etc., etc. Okay, perfect. So now what happened? We updated the family, so we added the new material. If we change any parameter, and so it will change. We rotated this, so this instance is now in another position, and then this was added again, right? So let's delete this that is new, and as always, we can go back to the V1, which will go back to that specific point in time, okay? Perfect. So that's a way to use blocks and update maybe block locations. So you can move around your blocks, and you will move around the blocks, the instances in Revit. Of course, we cannot undelete things, so that information is not available. So if you added more objects, you might want to delete them manually, but for existing objects, we can still move them around into new locations, okay, while we update parameters, geometry, and so on. All right? So this is the interesting workflow, but we can also do a little bit more with blocks. We can use blocks to place native families, right? And so I will also want to introduce some new, I will try to open Mauro if I can find still the ugly house project. Let's see if I can find it. Just give me a second. I think it should be Revit 2022.
I'm really curious. What is the ugly house project? Is it a Revit sample file?
Sample file that we always use. People hate it, but it's so iconic, I would say. But I'm not sure if you can help me to find the sample house location. Just if you bear with me a second, because I would prefer to use the old chairs. Let's see if I can find it. I thought they were okay. Let's see it. Okay, yes, that's the one. Oh, RBT, I need. Maybe I don't have it anymore. Well, I can try to use something else. I'm sure if Mauro is still in the call too. But I'll use the new examples. I'm not a big fan of these, but That's what we have. Okay, so the idea is that we will use blocks in Rhino to drive native families or any other family really that we want to place, and that could be useful to do. Let's see, still opening. Okay, maybe we have something in this file that I can use. Let's go to furniture, dining chair. Okay, this is the chair that I want. So imagine I have this chair here, and I want to place these in Revit. Okay, but I don't want to do it manually. Maybe I want to use some scripts with Grasshopper and so on. I want to be smart about it. So first, I will start, hinting of a tool that we use to send data from Revit to Rhino, so Ray. As I click it, I have a few options of what I want to export from Revit. So I can export edges, so I would pick edges. That's very useful if you want to take some lines as like a reference for location that will be geolocated correctly. I can pick grids and curves as well that are laying around. Anything in the active view, be careful with this, right? Don't use it, use it with attention. We can export solid elements, also adaptive components, which will only export the polylines that make the adaptive components, and we can also export parameters and materials. So in case, for example, for the question before, can we import share parameters? Yes, in a way, because with parameters and materials, you can pick project parameters that you have, send them to Rhino, and then in Rhino you could import the parameters from Revit, and also materials. For example, if I want to have a lot of materials from Revit in my Rhino collection, I can do so. I can show that later, but let's keep it to solid elements. So I'll pick the chair, press finish, call it chair. Then you can pick which version of Rhino you want to use to do all these operations, because we need to run Rhino in the background. In this case, I will just keep Rhino 8. I might get some dialogues of some plugins not opening, but we can ignore those. Okay, so it would this only happens the first time you open Ray. After it will be already loaded, so it will be much faster. Okay, now in a few seconds you should export. Perfect. So now when I go to Rhino, let's close this. I can go to Ray, and then I can pick things that I have exported. So chair is the latest one. This will always use the BEAM folders, okay? And now I have my chair imported, okay? So if everything works fine, it also would come with materials, will be grouped as one group, and in the data field of the panel, you can see where it comes from, okay? But it will look exactly like in Revit. Let's go back to shading. So one thing I will do, and I will just keep it simple here, but you can, if you get the point of this exercise, you will understand what I mean. So I will create a little block that represents this chair. Okay. Create a block, and let's put insertion point here. Doesn't matter. I can even leave it as block 1. Okay. Now this block, I can move it around like this, like so. And now let's move it up. And then I can export these blocks. So select them and click blocks and say share locations. It is exported. Go to Revit. And now using blocks, I will not use import family, but I will use existing, using share locations. So automatic will use the block name to find the family in the file. In this case, we will do the second time, but for now I will just pick my dining share 3. Okay, default settings here, we know that this is an always vertical family, so we cannot rotate it upside down. So this gives you a hint of what it is. For example, if I take unit 1, you will say it's workplane based, so we can use a block transformation in another location. But let's keep it as dining chair 3 and just press B. Now, as you can see, it placed my families in the block locations. And what I can do as well, if I'm not happy, I can also move these to another location. Maybe remove this as well. If I export the same blocks, new locations. Okay, you of course, I'm going quick here, but you can choose a better name. So blocks, use existing, and then pick my dining chair 3. This will move them to the new location. And the convenience of having names here is that I can also put other stuff. For example, I want to put a baluster in the same location. You will put the baluster in the same location, so you can maybe place the planter and the tree all together in the same spot by using that. And you keep a lightweight version of the file of the model here. Another thing we can do.
Just one thing. Sorry for interrupting you. Ted asked a question about importing families. Is it possible to import nested families to Rhino?
So we have now all the nested blocks will be exploded to the main holder block at the top level. But we have in our roadmap that eventually we will also allow the creation of let's say, nested families. But as of now, anything that is nested inside the block will be just exploded to the top level. Okay, so let's make something here just to spice it up. So I will open this family. It may take a second to open. Okay, then I will add a parameter here that I will call big H. Okay, and it's an instance parameter. Perfect. So and load it back into my demo project. So now I have this H parameter, and this H parameter will control the height of the seating, right? So in Rhino, I can create the same parameter. So I can add a big H parameter instance, make it length, and add it to all categories. I have my big H parameter. Press OK. Now in the blocks, I have this value, right? So I can say 1 meter, 2 meters, 3 meters, right? So I have assigned these as instance parameters. One way to do that, and maybe we're not covering enough our new feature, query. Query allows you to schedule and modify parameters. So let's add one, and let's call it chair heights. Right, so now I can pick what parameters. I will use my family. I will add maybe the level, category, maybe move this up. So it's family, category, level, and then my H parameter. Maybe I will add also a comment because I want to be able to change that, right? So when I press OK, now I have my schedule that is showing, well, this is not needed now. I think it's the other block. So I have my 3 blocks. And each one has their own value. If I want to make a change, I can do so here. So I can make this 2.5, maybe this is 0.5, so I can make this change. I can also group things. For example, if I want to group by family, it will have 3 families of block 1. Varies, of course, is the H. I can group by multiple things at the same time. So maybe I can group by H afterwards. And this, of course, will separate them. But if I set these to 2, it will group them. So I have 2 instances of block 1 with the height 2, H2, and 1 instance with 2.5. And I can also filter, for example, I want to filter by H if it's greater or equal than 2. This will hide everything that has no value, for example. So I can add more filters, either in AND or. So I can add another filter, for example, the family must equal block 01, and so on, right? And next, we can also format based on the value. So for example, I will add a formatting to say with an AND. Okay, so I can add more rules, several rules for this color. So I will add one, for example, if H is greater or equal than 2.2, okay, or maybe is less than or equal 1, I will make it red, right? Press OK. And then I will also add one where if H equals 2 is green. Now it will color my entries and format them based on this value. So when I click OK, I can change these maybe to 3 and change these to 1. I will make a copy as well, so I can add more values. Now, if I go to Q, I can still go to share heights, and I have updated values. So I can see that actually all of these are red and so on. So we can use the schedules to keep track and modify the value. So I see this actually should be maybe 2. That will make it better, and so on, right? Okay. So let's go back to here. So I have my blocks with my parameters. Now they're all updated to the latest value, and I can just select them, press blocks, and say adjusted seats. And it's now exported. So I can go to Revit, go to blocks, use existing, automatic. If I would have named the block dining chair 3, okay, we can actually try that if it's not clear, but I will just pick from the list. As I press OK, you will move them to the location if they were moved, but also assign the instance parameter that I have set. So you can assign material text, numerical values, whatever you want. So to drive properties of these native families directly from Rhino very easily. And that's with blocks. So many options here that you can use to use blocks, either importing geometry or just driving actually families. Okay. Hopefully everything is clear so far. We can move on to adaptive components, which is also a very nice, interesting workflow. So here I have created, I will say again, I know, Chris, what do you think? But I have a not really complicated, like a piece of roof, just for the
standard roof over like standard school, right?
Exactly. So something you will see every day. So what we have created a bunch of curves here, and this curve will represent adaptive components in Revit. So adaptive components, you might be aware of, they are elements that are placed based on a series of points, ordered points, which basically is a polyline, if you ask me, like when you have a series of ordered points is a polyline. And so by creating polylines or lines, in case it's only 2 points, of course, or points in case it's 1 point, so points, lines, and polylines, you can place adaptive components in Revit from Rhino and also modify these parameters. So here I have my cable family. So if I go to components and I go to cable, okay, so I have my cable family, and this cable has 2-point adaptives. Okay, so when I click actually the family, okay, see 1 and 2. I have another family here which actually has 6 points. So let's find it, adapt 6 points. I really need to stop these reminders getting crazy. Okay, so now this is 1, 2, 3, 4, 5, 6 points, right? So now if I click it, you can see it has 3 points, and they're ordered. So if you create a line or a polyline here, you would place these components from Rhino. Okay. Also, this family has a radius parameter. Okay. And also a material parameter, but let's focus on the radius. So first thing I will do, I will go to my Rhino file. And actually, just to make it fast today, I will just pick these. Maybe I can isolate them. Just for now, just to make it easier to see. So here I would have my radius 150, 150, etc. Maybe these 3, I will make them 200 millimeters. You can see I have created previously a radius parameter of type length, and this is a millimeters file, so it will be in millimeters. So I have these curves, so it's a line, and also what is convenient is that you can assign them to a family. This will just be a way to group them easily. So for example, if I look for curves, I will have central curves, edge curves, top curves. So you can use them as selection sets, right? So easily you can go to the top curves and change the radius to maybe 200. Okay, so that will make it easier to do. You can also use query to do that, but let's go back to our piece here. So I'll isolate them so it's easier to see. So now I have my geometry, and in a curve, everything is an instance parameter. So all the instance parameters are available. You don't have a category visible. And so you can see all the parameters. Now I can press beam and say cables. Right, so I have 5 elements. So if I go to Revit, go to Ursa this time. Ursa looks like a Ursa constellation from the sky, but it also looks like an adaptive component. It's a wireframe. So when I click it, similar to blocks, so we'll have, of course, my list of exported BEAM files, my access to the directory, and then families I can use. And this is a shortcut to see how many points you would use. So I have a 6-point adaptive. I have 2-point adaptive, which is cable. That's what I'm looking for. Okay, default settings, internal origin, all of that as well, same as always. And I can press beam. Somewhere in my file, I will have my adaptive components. Sorry, I have to just make Revit zoom a little bit better. As you can see, I have my cables, radius 200, radius 150, and so on. And now the magic is that also those have a mark assigned. So if I go here, let's say I move them like this. And then also I want to make these smaller, so I make them 50, right? And select these guys, say new cables. Go to Revit, Ursa, pick my family, so cable. New cables is pre-selected. And then you should update the new shape. If I'm not happy, I can always go back to cables and then pick cable again, press B, and it will go back to the previous version. So very easy to place adaptive components. And in conjunction with Ray, we can do a few cool things. For example, let's hope it's not too heavy, but actually, no, I can zoom here. Let's do this. If I have a blank new file, maybe I have a file with already adaptive components and I want to move them. You know that in Revit it's not super easy to move these things. You know, it's not the best, super convenient way. You cannot select all the points at once, or maybe you want to use Grasshopper to do that. So one thing you can do, you can go on Ray, say adaptive components, and it will pick all of the adaptives. Okay, and we'll see a few things in Grasshopper after this. So I go to Ray, I have my adaptives, and now in my file, I will have my curves. Okay, so instead of the geometry, the solid, we have now the adaptive component with a mark and everything. So now we can start, you know, modifying these. If I want to, I can now move these up, export them.
So lines are always the center line of an object?
Depends on your adaptive component. It really just connects the 2 points. Okay, so this 1 and 2. So of course the line is between this point and this point. This adaptive component that we have, but it depends on the adaptive component. In this case, it's a center line because it's the most convenient way. So I go back to cable. And you can see I was able to use that. So in my demo, I have a combined example to show. For example, I have this ramp, okay, and this ramp has a solid piece, which is a type floor, okay, and then it has some glazing around it, which is a panel of 6. So I have my polyline of 6 points. So I can even select everything and say ramp. Okay, it will export in a second. Then go to Revit, and I will do it in 2 steps. First time I will import the ramp. We'll actually change this to direct shape just because it's faster. Okay, of course, it says that panels did not have geometry because those were the curves, so I can ignore this. And now I have my ramp imported as a ramp, as a floor. Next, I will go to Ursa, use this ramp import, use 6 points adaptive. You will look for anything inside that is available that matches the number of points. Okay, so you can see I have placed my family. And because this is all connected, if I do this, for example, I can say ramp 2. And now first update the ramp to system families, and I will say first update. Okay, so this is done, and now from 2, 6 points. Perfect. Okay, so I have updated my geometry very easily to the new shape, right? Other works we can do, for example, just one last couple of bits. I mean, not sure how much time we have left. But for example, this is a combined workflow where we have a mass object, building mass, we have our context in generic model, and then we have some points that represent trees. Okay, so I will select everything and say city. Now go to Revit, and I will start importing the massing. So just city, default settings. Let's do it. It will give me a warning about the trees, but I can say I ignore this. So somewhere in my file, I have now my tower, and it's a mass, and I have my context around it. Then I will pick Ursa, pick city, and then I will look for my planting. So I have my tree here, which uses 1 point. And now it places the trees. I can start updating things. For example, I can pick this mass and make it bigger. So I'll say tower. And I will also move these trees to the right, to the left. Okay, and say new trees. So I exported twice in a row. Okay, just so I have 2 steps. So first, I will go to tower and just update it. And it updates my mass. Also, if I had floors, you can cut them with floors, and you will update this every time I update the mass, so no problem. And then using Ursa, I will want to update the new trees, which is pre-selected. I just need to choose the same planting. And we'll move my trees in the new location. Okay, so I can use this in combination all the time to place in maybe trees, maybe have massing going on, place some adaptive components. Let's move a little bit with Grasshopper, just to prove another workflow. For example, if we have panelization like this, okay, and every piece is separate and different from each other, so we want to create families with parameters and so on. So I have prepared here a script that I will open now. All of these will be sent in the folder we will share with all the content, so you can follow up. I think it was in workshop 1. No, actually. These maybe we might want to share again, Mauro, the panels. Okay, let's go. I think it's in this folder. Perfect. Let me just open. Okay, I think is this one. It's an old file I had to find. Okay, so as you can see, I pick some geometry, add to this node some like a material subcategory, assign them to a layer if it was the case. Then I create some family names. I'll show here what comes out of it. So element 0, 0, 0, etc., etc. Then we have mark, comments, and panel area. Also some repeated parameters, all with this, repeating the objects or intertwining. What happens is that we have the families grafted like this. Then we have the list of parameters that we want to use. And then for each family, a branch, let's say, with the values, right? And then use assign family parameter node here, as also with the category assigned from here. And in fact, now, when I click the object, you see all of the metadata is added. And where is Grasshopper? And I can change some parameters, so keep an eye on this. So for example, if I want to change from Earth to Moon, I could do it, and it changes immediately. So I can control with Grasshopper and automate. So each parameter, each panel now is a different element. Let's query this actually. Let's create a new schedule, panels. Okay. Then I want the family, the category, I want the panel area, and maybe the status type, location, a bunch of parameters, okay? This will give me all of them. Maybe the type is not needed, so let's remove it. Okay, and the owner as well. Let's just keep things that have values. Okay, so now I have my parameters. I can also, search here. So if I want to search for a specific value, I can quickly, but I can also say filter, and I will filter out things that have has value. Okay, so all the families that don't have panel area will be filtered out. Okay, and then I can see all the values here. I can export to Excel, for example, or I can find a specific panel. So if I click this and I click OK, this will be always available to me in my panels schedule, right? So be aware of this. Scheduling is quite important and good to have. So now I can export all of these as panels. Okay, it's a slightly complicated geometry. At some points it has some trimming that are a bit excessive, but that's okay. And so now in BEAM, what I will do, this is a bit of more advanced workflow. I would say I would use them as system components, because otherwise it will create a loadable family that will be super slow. We want to have direct shapes in this case. So I can just say system components, and now somewhere in my document here, you can see. Also, a good thing about BEAM is that you can cancel anytime compared to other tools. You can cancel your operation if it's taking too long. And one nice addition as well is that if you zoom in and out, you can see preview of things getting populated, right? So now it's creating my panelization.
And great that you can still move your view, that is not blocking, that you have to wait. So that is also great.
You can do that. Unless in specific moments where it's actually matching geometry, but in between every placement, you can still work on, for example, when you're placing blocks or when you're using Ursa. We'll try to make a big import, just to say. But let's have a look here. Maybe I didn't have all the parameters here, but I have my element 19 here, and I will have my parameters here. Maybe panel area I didn't create in this file, but any parameters you need will be here. And so you can also do the scheduling in Revit and have these modeled properly here, right? Because we can also create a parameter that represents the type of objects. Although you will say here panel 19 underscore element underscore 13, in Revit, you can create a parameter that will be grouping all of these in a schedule, right? Not sure how good you guys are with Revit, but if I created a parameter called type or panel type, and you say covering, I don't know, you would be able to group them by that, although the family name is different. So you could ignore these. This just because how Revit works, we are forced to do this way, because we cannot have the same name for different geometries unless it's a parametric family. But in this case, we cannot even generate some of these shapes in Revit natively, especially these let's say double curved objects. So the workaround is to create a family or a direct shape for each element, and then use another parameter, for example, a type parameter, to group them in a schedule like they were the same component. So in the scheduling, you can get away with this type of setup. Okay. So that was it. I was about to show the Ursa, just to say might take a little bit to import, but let's see how fast it is. So let's say all cables. Okay, so it's 1700 cables. So I can go to Ursa, pick my cable family, and see what happens. So now it will start importing. Might be a bit too much. Now I think it's unpacking the file. So just give me a second. But do we have questions in the meantime?
No, I cannot see, but please join us if you are watching, and just write if you find all these workflows useful for creating families, for editing. Maybe you can also write what is missing, what you've been expecting. Maybe you can also, Mikael, say which of the workflow is most used by designers. What is the most feedback you get? which one you feel is the greatest of the options that you have with connection with Revit?
Well, BEAM and blocks definitely are the most used workflows for sure. So those are the main workflows. Although we feel that many people are limiting themselves to using BEAM Blue and just the kind of in-place workflow. That's the easiest one to apply. But with blocks and maybe by using Rhino as a family template, you can be, it's very effective, and you can go, even further in the design process in the phases.
Mm-hmm. Maybe we can at the end. We can also come back if it's that all that you wanted to present from Revit BEAM workflow. Maybe we go to RhinoSync. What do you think?
Yeah, we could do that. Maybe Mauro can join it.
Mm-hmm. Just Mauro, let us know if you would like to join so we can test it. And yeah, hello, Mauro. You're muted. So we cannot hear.
Yes.
Yeah.
Hello.
Perfect. Yeah. For those who are watching us, please write if you have any questions. We answered all of them in the meantime. And yeah, you can just share your screen so we can see about RhinoSync, how we can work together, several users from different places. For sure, you got this question several times. Is it possible to make similar work for Grasshopper with RhinoSync?
Maybe at some point we'll get into that. First, we are solving Rhino, and then maybe we can think about Grasshopper. But you can still use Grasshopper to collaborate on the same file, so that's possible. Yeah. On the same Grasshopper file, we can we need to look into that, but it might be feasible. Although you might go like step on each other's foot. Not sure. So we need to see if that's actually very convenient. But you can definitely use Grasshopper to collaborate on the same Rhino file. That's no problem with RhinoSync. So RhinoSync is a simple application. And actually, I'm opening two Rhinos here just so we can see at the same time. Actually, I asked for Mauro to join, but I think it would be better if
if you
sessions. So this is the RhinoSync panel. I will just create another user here, and actually I will impersonate Mauro in this context. So imagine this is a Rhino computer, and this is a separate Rhino computer. So I can start a collaboration session, and I can select what is my storage. It can be a shared network drive, or it can be Google Drive. Let's use Google Drive, which will ask me to sign in. Okay. Allow permission to pick on one file, then I'll go to my maybe share drive, and then pick a 3DM file. Okay. Then I will do the same on the right. Okay, so I will do it off screen, so it's easier. So share drive, untitled, perfect. So now, as you can see, I have my users panel, where I can see, maybe Mauro can join a third person if you want to, maybe as another nickname. But I have a Mauro and a Mikael connected. So this is, of course, your user, and then whoever is connected, so it's a burst. Then a log area where we can get information about the current session, and then also a chat, so you can say ciao. And I can talk between people that join the same session of the file. Next, we can start modifying objects or creating objects. For example, here I will move this piece of geometry. And if on this Rhino I try to edit it, it will not let me because some other user owns it. And I can check which user owns it. So if I click on Mauro, it will color in Mauro's color the object Mauro owns. So until Mauro synchronizes his changes, I cannot edit this object. But I can pick other stuff. For example, I can move these two. And these will be owned by me. Okay, so as you can see, so Mauro cannot modify them. So in both ways is possible. I can add new geometry. For example, I will add this geometry. Maybe in this case, Mauro will want to create, to rename a layer to test. Maybe I want to work in this way, so I will just pop out my collaboration tools, so I can have them floating, and I can go to my layer, so you can see now AAA was modified by Mauro, so I cannot modify this. It will go back. And so now I have my, I have done a bunch of changes. Maybe I can change some material and so on, but let's start synchronizing. So for example, Mauro will synchronize first, and we will see here the synchronization icon pop by because Mauro has synchronized, and it will be done. So he pushed his changes to the central, okay? And I still own these objects. And now maybe I'm not ready to push my changes, but I want to download Mauro's changes. So I'll just click reload, and this will download Mauro's changes. So for example, this changed to test, and the geometry moved to the location where Mauro moved. Now maybe I'm done with my changes, so now I will also synchronize, and Mauro will do the same and synchronize. Okay, so now as you can see, we have the same file with the same layers, same geometry, and maybe same materials and so on. And so this is, in a nutshell, how RhinoSync works. And is free to use now in this alpha phase. You can test it as much as you want. It works, as I said, with Google Drive or network drives disks. And we hope it will be kind of a small revolution in the way of working for Rhino, so you can actually enhance your collaboration and maybe instead of splitting the files in multiple parts and then someone has to join them back and forth, this will simplify much more your collaborative efforts in parts of your project. Okay, I'm sure if there are any questions or if Chris, what do you think about this?
I think that RhinoSync can really change, especially in the big companies that more and more are using Rhino. We all know that Revit is the main tool still in our industry, but this can help a lot. I mean, a lot. If there's more and more projects being done in Rhino, working that together, it helps. As you mentioned, like maybe in Grasshopper it's not the best idea because that can cause more troubles than maybe it's easier to manage, but maybe we'll see if it will be developed more and more users will use that. So that it's cool to see. When do you have time to develop new tools? Like when the idea came with this RhinoSync?
Yeah,
just maybe. In the meantime, like doing your own business, like, okay, maybe we should create new product.
Yeah, exactly. So it's always a challenge to find time, and that's why it's important to let's say focus on what matters, right? And we thought that what Rhino was missing to be fully BEAM, to be able to be in the paradigm of tools that something that we like about Revit is the collaboration aspect and the BEAM aspect of it, And so we thought, like, what Rhino needs to be on same part. So we added the layer of information, and we've seen that today with Rhino to Revit, and actually yesterday even more with Rhino IFC by adding all the metadata, creating the objects, and then you need to be able to collaborate, and you collaborate in two ways: with interoperability, so by sharing assets that are understandable by all, but also you can collaborate internally, so a way to actually facilitate this teamwork. And that's why we decided that RhinoSync maybe was a good idea to follow, and it was kind of a prototype idea. We used some weird exotic tech that is not common for these type of products, but we use them in this way, and it's looking up nicely, and hopefully it will change a lot in the industry.
Yeah, perfect. Thank you. We had some question from JG. Is there any user manual available PDF similar to Rhino level 1 and level 2, where we can find all the definition and topics from the beginning for those who are not experts and sufficient trained? And in the meantime, I got the message from Mauro that he is recommending this, then the website. This is the wiki website. Yeah, Mauro, maybe you can join us. So you can maybe explain what we are seeing on my screen.
Yeah, so JG. So we were. So you can find a lot of information on the page, on the wiki page, both for BEAM. As you can see, you can go through BEAM from Rhino. So you can start by creating the family and everything that Mikael went through today in the demo. Also, we have information about the licensing, the deployment, and everything. So make sure to visit this website. And recently, so yeah, BEAM for Revit, and so a lot of information, tips and tricks about all the features that we have shown today. We also
Great. By the way, great stuff doing the wiki. It's really important, and yeah, kudos for you.
We need to update it with the new version, so there will be a bit of an overhaul of a few parts once we release 1.13. And we are also working on a series of new updated tutorials, because there is a few videos in the wiki, but we want to have more bite-sized tutorials for each individual part of it. But at any point, if you work in a company that uses BEAM, let us know if you need a workshop. We're always happy to give 1 hour free workshops to you and your team. So if any of you is interested in are being users and want to make use of that, just let us know. We're happy to set up more workshops and hands-on experiences, or even ask any questions. Our email is on info@mksdtech.com. So just write us a couple of lines, we can help.
Yeah,
that's amazing. Thank you for that openness.
Yeah, and also we have, just because we were talking about RhinoSync, we have the same wiki for RhinoSync. Actually, Chris, maybe it might be a good time you can go to our website, so you can click on both of them. You can show both the pages of BEAM and RhinoSync, so they can go. Let me share with you in the chat.
Yeah.
Yes, so. Yeah, I mean, it's easy. mksdtech.com, and you can access both so our general homepage, and then here you can find more information about both BEAM and RhinoSync and what we do, wiki page, and so on. So I think it's good to check it out. You can download it. RhinoSync is free at the moment, alpha version, and but also if you want to click on the wiki page, if you scroll down in this page, so wiki, yes, above, yes, wiki, yeah. So we have the same information for RhinoSync from the start, installation and everything. So
perfect, nice, great stuff. And yeah, also adding a little bit about question was for both BEAM and Grasshopper. From my side, for Grasshopper, I can really recommend that I have created 5 steps to learn Grasshopper. This book contains lots of free materials that are available from the basic to more advanced stuff, how to start with data trees, how to learn components, what are the most important components. So I will also share that link. And as always, I always recommend to join my newsletter, free newsletter. I already have 17,000 architects and engineers on my newsletters. Weekly, I'm sending new learning materials, invitation to new workshops like today, amazing workshop with Mauro and Mikael. So you can stay updated with great learning materials. All right, just one more thing I would like to mention, that in 1st of October, we're going to have a new workshop. We are going to continue talk about Revit, and this time we are going to use Grasshopper as a bridge between Revit and finite element software. So we are going to have lots of guests there, and we are going to show how we connect to Sophistic, FemDesign, ETAP, SAP 2000 directly through Grasshopper. So if you are on the list, my mailing list, so you will get more information. There been one more question for you, Mikael. Do the file size of complex elements stay small, or are they as large as in Revit? Maybe the question, is it any way to maybe optimize the size of the families or Revit?
So as always, especially if you're doing Rhino to Revit workflow, is the amount of points of your surfaces that will matter, how big, how heavy it is. So by reducing the point count on the surfaces, even if on a poly surface, and also the point count on curves, that will reduce the file size and the size of the geometry, because that has to be stored. All the coordinates of those points have to be stored and have also to be processed. So when you press F10 in Rhino, it's a good way to see all the control points of your surfaces. So the less you have, the lighter the geometry is.
Perfect. All right. Thank you very much. Thank you for your time and doing this great workshop, as we talked at the start. Let's continue. There's more and more interest of people that would like to use Rhino as a BEAM machines. They would like to do not use Revit, Tekla, or other software and just go directly for Revit. So thanks for making this possible and actually changing our industry. So thank you guys for the great job that you are doing. And let's please stay on this line so we can also talk about these files that we are going to share for everyone. Just in 1 hour, everyone's supposed to get all the files that been presented. So again, thank you very much, and yeah, cheers. See you next time.
Please, and thank you for everyone that attended.
Thank you, everyone.
Bye-bye.